We live in a time where we can actually answer questions about the universe that we see when we look into the night sky, but there are still mysteries that remain to be solved.
SPHEREx and PUNCH are two completely different missions that are sharing a ride together to space. SPHEREx is a telescope that takes images of our skies in infrared. We're going to take thousands of pictures forming a map of our universe. We're trying to look back in time to see what happened in the first second after the Big Bang.
PUNCH is a constellation of 4 small satellites. It's focused on the sun's outer atmosphere, the solar corona, and how that solar atmosphere fills our solar system and bombards Earth's magnetic field.
It's going to be the most complete all-sky survey that we've ever done.
Being able to see basically back in time, it's cool. It's like time travel.
We can expect some surprises in this process.
Together, SPHEREx and PUNCH highlight NASA's mission to not only explore the cosmos, but to unravel the deeper connections that bind us all.
3, 2, 1, and liftoff. Hello and welcome. I'm NASA's Raquel Villanueva, and thank you so much for joining us today for the SPHEREx and PUNCH pre-launch briefing. With this one launch, there are 2 missions. First up, SPHEREx, a space telescope that will scan the sky in infrared and create an all-sky map. And PUNCH, 4 small satellites that will study the sun's outer atmosphere and give us new insight into the solar wind. NASA just wrapped up a successful launch readiness review, and we are marching toward a launch attempt tomorrow, March 8th, from Vandenberg Space Force Base. The 30-second launch window opens at 7:09 p.m. Pacific Time. To talk to us about today's review, we have Mark Clampin, Acting Deputy Associate Administrator, Science Mission Directorate at NASA Headquarters; Jim Fanson, SPHEREx Project Manager at NASA's Jet Propulsion Laboratory; David Cheney, PUNCH Program Executive at NASA; Denton Gibson, Launch Manager for NASA's Launch Services Program; Juliana Scheinman, Director, NASA Science Missions, SpaceX; and U.S. Air Force First Lieutenant Ina Park, 30th Operations Support Squadron, Launch Weather Officer. So each have some opening remarks before we get started, and then we'll take reporter questions. If you are on the phone line, press *1 to get put in the queue and *2 to get out. We are also taking live social media questions, so if you have a question you'd like to ask, use the hashtag AskNASA on NASA's social media channels or drop a comment where you are watching. I will now hand it over to Mark.
Thank you very much. So I'm really pleased to be here. We're one day from the launch of 2 NASA science missions, SPHEREx and PUNCH. And this is a real change in how we do business. We call this a ride share, and it's a new strategy that SMD is working where we can maximize the efficiency of launches by flying 2 payloads at once, so we maximize our science return. So the other thing I think is really important to understand is not only are we, launching 2 missions at once, but these missions cover the full breadth of the science that NASA does every day. So we're really excited by this launch. PUNCH is a constellation. It's actually 4 satellites, and it will study a single nearby star, our sun, in great detail, whereas SPHEREx is a survey mission that will scan the full sky and will observe, hundreds of millions of stars. So every minute of the day, NASA's science missions are exploring the universe at different scales to really help us understand the universe we live in and understand the sun that keeps our planet alive. SPHEREx is a high-precision spectroscopic survey mission, so it will map the entire sky in the infrared and give us really our first understanding of a number of new astrophysical ideas. One of those is really trying to understand the early universe, and it will also help us fill in pieces of other cosmic puzzles. And it will complement the rest of our astrophysics portfolio, because it's a North Sky survey, and it informs our other missions, which are more directed in terms of being point-and-shoot missions. So together, they really allow us to sort of leverage the investment we've made in all these science missions. PUNCH gives us a brand new 3D measurement of the sun's outer atmosphere with tremendous detail, and it would really allow us to clarify the changes in how solar wind is driven by eruptions from the sun. And it's very important that we understand this, which we call space weather, because it really impacts the Earth and the planet we live on, and can have pretty significant impacts on our society and technology. So these bursts, they're the kind of innovation that we do at NASA, and we're always trying to push the boundaries of what is possible and to look further, look in more detail at the universe and the world we live in. So every day, our missions build upon each other, and each individual instrument or spacecraft contributes another piece to our understanding of our universe. The data from these missions, it's important to mention, will be publicly available to everybody. So we're also generating more discovery by making the data available, allowing other people to use it, and use it for different problems that we may not have thought about when we were designing these missions. And that's always been one of the benefits of NASA's missions, that we do these primary science goals with these missions, but there's always additional science that comes from people looking at the data and finding new ways to use it to answer different questions, whether it be about the sun or about astrophysics. So with that, I will finish up, and to tell you more about SPHEREx is Jim Fanson, the project manager for SPHEREx at NASA JPL.
Thank you, Mark. Well, SPHEREx is ready to launch and map the universe in a way that no space telescope has done before. If I can have the first image, please. We're now fully integrated with the Falcon 9 rocket. On launch day, the team at Vandenberg will be performing final telemetry checks and charging the battery in preparation for the launch countdown. At the JPL Operations Center, also called the EO Mach, flight controllers will be preparing to catch the spacecraft once it reaches orbit over Antarctica, establish communication, and assess its state of health. I'd like to acknowledge the dedicated effort of the SPHEREx team at JPL, at Caltech, at IPAC, at our contractor, BAE Systems, the Korea Astronomy and Space Science Institute, the many other scientific institutions that have been involved in the mission, and of course NASA's Launch Services Program and the Near Space Network, and our launch provider, SpaceX. Liftoff is just the beginning. Key milestones that the team will be watching include the spacecraft separation from the launch vehicle, which occurs about 42 minutes after launch. We then have several opportunities to acquire signal from the spacecraft. The first opportunity will be over Antarctica. We could acquire the signal between 1 and 3 minutes after spacecraft separation. The second opportunity is 47 minutes after separation over the island of Svalbard in the Arctic. This is also our first opportunity to send a command to the spacecraft. The third opportunity to acquire signal is over Fairbanks, Alaska, at approximately 63 minutes after separation. So within about an hour from separation, we have 3 opportunities to acquire signal from the spacecraft. The spacecraft should be power positive within the first 3 minutes of separation, with sunlight illuminating the solar panel. The vehicle can operate on battery power alone without any sunlight on the solar panel for several hours. Additional milestones include the release of the telescope cover. It's a kind of lens cap over the telescope, which will occur on day 4. Countdown and outgassing of moisture and other contaminants over the next 2 weeks. Turning on the imaging sensors when the temperature is cold enough and collecting engineering data for processing on the ground. And various scientific and engineering calibrations, tests, and practice surveys that will continue for about 37 days after launch, at which point the science survey will commence. If I can have the animation video, please. The SPHEREx spacecraft and mission are designed to keep the telescope extremely cold. 360 degrees below 0 Fahrenheit, or about 218 degrees below 0 Celsius. We have 3 cone-shaped photon shields that protect the instrument and give it its distinctive shape, enclosing the instrument at the center of these photon shields and protecting it from sunlight and from earth shine. The observatory will be in a dawn-dusk sun-synchronous polar orbit around the Earth, which means that it always stays in sunlight, keeping the instrument at a steady temperature and assuring constant electrical power. During its 2-year baseline mission, SPHEREx will image the entire cosmic sky in 102 infrared colors, map the three-dimensional positions of more than 400 million galaxies across cosmic time. We want to better understand what happened in the moments right after the Big Bang at the origin of the universe, when the universe is believed to have experienced a sudden, dramatic, rapid expansion called cosmic inflation. We also want to find out how much water is out there. SPHEREx will probe interstellar clouds of ices, 4 ices made of water and other molecules. And finally, this mission will provide a rich archive of data that will enable many scientific studies by the astronomy community for decades to come. We're 1 day from launch, and what's going through my mind right now is to assure that we complete the final preparations for launch and early operations, both at the launch site and at the Mission Operations Center at JPL. Our entire team is eager to take this first step on the road to the stars. I'd like now to hand it over to Dave Cheney, who is the PUNCH Program Executive.
Thank you, Jim. So PUNCH is a mission to study the sun, which we like to call heliophysics. It is measuring trying to measure how we actually understand the solar wind that fills the whole universe. So in order to do that, we have 4 different spacecraft. You have one that's a coronagraph that has an area that blocks out the sun, so it can measure the corona of the sun. And then it has 3 other spacecraft to measure the very faint solar wind, so we can then stitch those together, and then we can then with those images that basically become one instrument, we can then understand the 3-dimensional aspect of the solar wind and how it progresses as it moves towards the Earth. With that understanding, we can better understand how the sun impacts space weather, and all the things that we get from the space with space weather. All our technology that's in space is all impacted by space weather. PUNCH is ready for launch. We're very excited to be there. We will be turned off for launch, so we will be sitting there just waiting. About 50 minutes after the launch, that's when we'll separate, and then over the course of an hour after separation, we should be able to have an opportunity to contact all 4 spacecraft and verify that they are ready to go. PUNCH will actually then undergo a 90-day commissioning, where during that commissioning they're spacing out around the Earth so that the 3 spacecraft that are merging in with the center one can actually get equally spaced around the Earth, so we can get that one single image. And we're just really excited, super excited. Go PUNCH, go SPHEREx, and go Falcon 9. And over to you, Denton, from Launch Services.
Hello, I'm Denton Gibson. I am the NASA Launch Director for the SPHEREx and PUNCH mission, and I'm humbled to be here. And I'm also excited to be part of this amazing team. We've been working diligently to get to this point. And I just want to take a minute to recognize NASA, SpaceX, the JPL team, as well as the U.S. Space Force Space Launch Delta 30, that dream team of professionals that's helped us get to this point. We'll be launching the SPHEREx and PUNCH mission tomorrow, and we've run into a lot of challenges along the way. A lot of those challenges have caused us some launch delays, but this team has pulled together and worked diligently to get us over that. Yesterday, we mated the spacecraft to the launch vehicle, and I would just like to play a video now, and we go ahead and play the video, please. So, mid-January, we had the spacecraft arriving. That was the SPHEREx spacecraft that arrived there. You can see some good shots there. And next, we also had about 4 days later, we had the PUNCH quartet of spacecraft arriving, and you can see them there. That's a good shot there of them being mated to the secondary adapters there. And then you have a good video of encapsulation. This is the encapsulating the stack, which includes the SPHEREx and the PUNCH spacecraft. And it's just a representative video of what rollout looks like. Rollout will be occurring later this afternoon. And that's just a representative video there, and that's what the Falcon 9 would look like sitting on the pad here at Slick 4 at Vandenberg. And there's some good video shots there of the launch vehicle and what we hope to be seeing tomorrow evening. So this morning we held the joint NASA SpaceX launch vehicle readiness review, where the joint teams had given their go to proceed into launch tomorrow evening. We also have the Space Launch Delta 30 launch readiness review later this afternoon, where we expect the Space Force to give their approval to go into launch tomorrow evening. So tomorrow evening, we'll be finishing final vehicle preps as we go through the countdown, about 40 minutes ahead of that launch time, which would be 7:10 p.m. Pacific time tomorrow. We will give the final go for propellant loading and readiness to launch. Once the propellants are loaded and we complete stage 1 and stage 2 propellant loading, and after completion of final vehicle checkouts, the team will be ready to launch this mission and collect this amazing, as you heard, science from the SPHEREx and both PUNCH and the PUNCH spacecrafts as well. We'll be ready to launch this thing at 7:10 p.m. tomorrow evening. And the team is ready to go tomorrow evening. And turn over you, Juliana.
Yeah, thank you. As Denton said, I think we can all here say we are very excited to be at this milestone, finishing LRR and here at this press conference before launch. Very excited to be here after a bit of delay. I wanted to start actually by thanking the teams that we're here with, NASA headquarters, NASA JPL, NASA Goddard, as well as BAE Systems and Southwest Research Institute for their partnership and teamwork ahead of this mission. We really wouldn't be here today if it wasn't for that great teamwork. And one of the reasons I mentioned so many names, as you've heard, is that this is a rideshare mission. This is our first rideshare mission for the NASA Launch Services Program, but actually we've had 14 dedicated rideshare missions since 2021. So we at SpaceX are big fans of rideshare and lowering the cost of access to space, but this is our first rideshare mission for the Launch Services Program, and it is one of many. Later this year, we have the Tracers and IMAP missions. Both are launching as rideshare missions with other commercial or science payloads. So it's a big rideshare year for Falcon and for NASA science. Very exciting. I personally came to SpaceX because I wanted to help lower the cost of access to space, which in turn helps us enable more scientific exploration. So I'm really proud that we can be doing that together. Falcon 9's demonstrated reliability, coupled with our rideshare capabilities, do enable launching payloads at a fraction of previous costs. So we're really proud and excited to be supporting science in this way. And actually, in fact, the booster that we are launching the SPHEREx Punch mission on actually flew one of those rideshare missions. It flew the transporter mission earlier this year, as well as a mission for the NRO. So this will be the third flight on this booster. But back to the SPHEREx mission, we at SpaceX are super excited to be launching this telescope that is going to help us understand the origin of the universe. It is missions like this that help us really pause and reflect on the vastness of space and what we all still have yet to explore. So it's really exciting for SpaceX. Also, as you heard Denton mention, everything's on track for the launch tomorrow at 7:10 p.m. And for those in the area, you are lucky, you're here for a treat, because the booster will come back to land about 8 minutes after launch, after liftoff, here back to land at Vandenberg Space Force Base. So for those in the area, make sure you keep your ears open for the thunder of the sonic booms we're very excited about. And with that, I will hand it over to the weather officer to make sure we have clear skies.
Yeah. Thank you, Juliana. Hello, everyone. My name is Lieutenant Park, and I'm the weather officer for this mission. I know that we've been experiencing some back-to-back storms for the past week, but I'm really excited to say that we are looking very good for this launch tomorrow. A system just passed over us a few days ago. and the next one isn't coming until Monday. So this weekend is looking great. Being in between two systems means that we're looking really good. We're going to have really good weather for this weekend. If you can please bring up the satellite imagery. So for tomorrow night's launch, that red circle off into the Pacific, that is slated to be over us for tomorrow night. We are looking dry all day tomorrow. We're not seeing any kind of significant clouds. We might see some high cirrus clouds, but they will be way too cold and way too thin and pretty sparse if we do see them to really cause any kind of impact. And so, except for that, and that's not going to cause any kind of problems for the launch, at least weather-wise. So we're not going to see any kind of problems. Winds will also be very light, and so overall it'll be a gorgeous day for tomorrow night. So we are ready to blast them and are 100% go for tomorrow night's launch. Backup day is also looking great. We are expecting some low and shallow stratus clouds, but we don't think it's going to grow high or be very cold. So there's a very high likelihood that is not going to impact and cause any kind of problems for this launch. For a little bit of background, if these shallow stratus clouds were to grow and become cold, that could cause an electric field to form within the cloud. And then we have a rocket that goes up into those clouds and disturbs that electric field and essentially becomes a gigantic, huge lightning rod. We don't want that, and that is called rocket-triggered lightning. And so that's why thick stratus cloud is a concern. However, these clouds that we're forecasting for backup day on Sunday will not grow to that height and cause this concern. So we are a 90% go for Sunday night. And that is all I have for weather. I hope that is really good news for everybody, for the team. And so, yeah, back to you, Raquel.
Absolutely. Thank you so much, Ina. And we are now ready to take questions on the phone line. Remember to press *1 to get put in the queue and *2 to get out. And our first question comes from Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks so much for taking the time to speak with us this afternoon. Want to direct my question to Mr. Gibson and to Joanna Scheinman, excuse me. Can you expound a little bit on the reason for the delays for this mission? It was sort of lightly touched on, but without any specifics. Was this at all connected to some previous issues with the Falcon 9 upper stage that were mentioned at previous briefings, or the booster that didn't land correctly and experienced a fire on the drone ship just read the instructions? Thanks.
Yeah, I can take that question. Yes, appreciate the opportunity to elaborate on that. I think the most important thing to note up front is, on behalf of all of the teams here, we only launch when we're ready, and that's the most important thing. We have a whole suite of teams that look through data, that participate in our operations, and at SpaceX, we only launch when we're ready to do so. For this campaign, we had a series of integration issues that came up that I'd be happy to speak about. One of them is we fly on this mission essentially a system that's used to mitigate the environments for the rocket launch. We call that an impedance mismatch assembly, but essentially it lowers the environments the spacecraft experiences on ascent. And that system has a series of inserts, 120 inserts, that during integration we realized had become ovalized. And so we needed to pause, first understand the issue, make sure that we had a safe path to fly. And once we were able to do that and install updated fasteners, we then proceeded through that operation to continue that installation. So that initial issue related to that environments mitigation system and that integration, that was a large portion of the delay. We also ran into an issue where, to step back, the SpaceX fairing is a pneumatically separated system. And we, every time we perform an encapsulation operation, after that we make sure that the pressure in the fairing pneumatic system is sufficient to eventually be able to separate that fairing in flight. And when we perform that check this time around, after the initial encapsulation, we discovered that there was a leak in the fairing pneumatic separation system. So we needed to de-encapsulate, repair the leak, and re-encapsulate. So those are some of the integration issues that caused the delays that you saw us slip the launch date for. We also had a lot of other issues outside of our control as well. We had a weather delay when we were trying to transport the encapsulated assembly from its payload processing facility to the launch site, because we don't want to do that in high winds or bad weather, and that's what we saw the first day we were trying to do that transport. And we also were working as on a non-interference basis for this launch with the high priority range operation that was occurring. And so we did one of those days need to stand down to support the higher priority range operation that was happening. And finally, we're here today once the rocket has been appropriately reviewed on all the data that we have. We are very excited that we have gotten to LRR and are here today.
Yeah, and I'd just like to add, as part of the NASA Launch Service Program team, is we work together with SpaceX to ensure that we've resolved all these issues and ensure that we are ready to step into launch tomorrow. And that was one of the biggest things that came out of our launch readiness review earlier today. Made sure that we were successfully past all of these challenges that we had to deal with, and we're ready to go tomorrow evening.
Great. Thank you. And up next on the phone line, we have Jeff Faust with Space News.
Good afternoon. Just to follow up on Will's question, while you were dealing with these other issues specific to the Falcon 9 being used for this mission, were there any reviews to look at some of the broader issues, the Falcon 9, again, the landing that didn't go according to plan, or I know there was an issue with the upper stage nozzle for one Falcon 9 that caused some last-minute investigations ahead of the IM-2 launch last week. Was that anything like that going on in parallel to fixing these issues? Thanks.
Yeah, I can take that one again. So we did what Jeff was referring to is on Sunday, when we were launching our G1220 Starlink mission, we had a successful ascent and deployed the Starlink payloads. When we were bringing the booster back to the drone ship to land, about 48 seconds or so after the drone ship landed, there was a fire on the vehicle, and that fire eventually resulted in the deterioration of the structural integrity of the landing leg, and that booster inevitably toppled over. And as with any issue with any one of our launches, we definitely want to make sure we're in a position where we're well positioned for the next launch. So we have been on the SpaceX side and the NASA Launch Services side, reviewed the data from that launch, reviewed to make sure that there's no concern or risk to ascent, especially for these important science missions. So that is a part of the process that we've run and done that review ahead of launch tomorrow.
Yeah, and as part of NASA Launch Service Program, one of our major roles is that we have a mission assurance role. So a lot of these evaluations we do independent of SpaceX to give it a fresh set of eyes, a different set of eyes, to ensure that we are not incurring any risk to our mission. And so we've gone through that process and we've gotten comfortable where we are, which is why we were able to successfully complete our launch our launch readiness review earlier today.
Thank you. And up next on the phone line is Stephen Clark with Ars Technica.
Hi, thanks for taking my question. I think one quick question for each of the representatives from PUNCH and SPHEREx. Can you share the total life cycle cost for each of those missions? And then for Clampin, can you take a step back and just broadly talk about where the Explorers program fits in your portfolio going forward for the Science Mission Directorate? And there's been a lot of discussion about cost savings with this rideshare approach, getting the cost of launch down. However, I wanted to see if NASA or you have any thoughts about perhaps ways in the future to get the cost of spacecraft and instruments down to make these missions more affordable and potentially at a higher cadence than they are flying today. Thanks.
Stephen, we had a little bit of trouble hearing you on the phone line. Could you repeat your question, specifically the second half of it?
Yes, sure. For Mark Clampin, in addition to the exact cost for SPHEREx and PUNCH that I had in my first part of my question, I just wanted to see if Mark has any thoughts on where the Explorers program fits in the SMD portfolio, and this mission, the rideshare approach, is reducing the cost of the launch portion of the mission. Any thoughts or initiatives or ideas going forward to reduce the cost of actually building the spacecraft bus and instruments and things like that to make these missions even more affordable? Thanks.
Okay, so let me start with the first part of your question. So the cost of SPHEREx is $488 million. And then for Punch, the cost is $150 million. And, of course, SPHEREx is a mid-class explorer, whereas Punch is a SMEX or a small explorer. So you asked what we're looking at going forward in terms of where the Explorer program fits in our portfolio. So, we have decadal in some of our divisions. We have decadal recommendations that kind of set the cadence for us. And I think it's widely recognized that the mid-class explorers tend to be missions that not only focus on a specific goal, but also allow us to provide a broad data set that serves the whole community. And SPHEREx is just a great example of that. In addition to their 3 primary science goals, they will produce this amazing data archive that can then be used by the whole science community to address a host of other questions that can address individual specific astrophysics areas that are probably not part of Jamie Bock's original proposal, because they've picked this mission and designed it to focus on specific areas. The SMEX, or the small class explorers, we regard those as being more a way of focusing on a specific science area, and quite often it's the first time that we've addressed a specific science problem. So the two we see as being very complementary to each other. In terms of what we could do in the future to lower the cost, I think the space business is constantly growing, and it's growing very fast right now. And we're seeing a lot more companies interested in providing spacecraft bus for us for these missions. And so we're always looking at ways that we can improve not just the efficiency of the programs, but the cost as well. And so if those opportunities arise, we will certainly try to take care of them. I think for the instruments, it's a harder question, because every observation we do in space science is really pushing the envelope of measurements that we made before. So it's a lot harder to look for cost savings when you really have to start with new technology that allows you to make that first measurement. So while on the instrument side we may not be able to find ways in the future of doing cost savings, what we are doing is enabling U.S. industry by developing new technologies that then subsequently bleed into other areas of industry. So I think it's a very good program that provides a lot of great science at a pretty reasonable cost when you look at the legacy that some of these missions leave behind, and how even now people are still using data for missions in the Explorer program that have flown years ago.
Thank you, Mark. And we'll also take some social media questions live. If you have a question you'd like to ask, use the hashtag AskNASA. Our first question is for David. Sammy Connor on YouTube wants to know, how is the solar wind affecting our magnetic field, and how will Punch study it?
Thanks for that question. The Punch is actually just going to be studying the solar wind itself, and so we can better understand when the solar wind is actually going to impact and if there are waves in the solar wind. But the specific results in the magnetic field are going to have to be studied by other missions.
Great, thank you. And we have another question in from Santarama Ganesh Nimor on YouTube, who asks, I'm curious about the range of SPHEREx. Can you tell me more? It's for you, Jim.
So the question is about what aspect of SPHEREx?
The range.
The range. SPHEREx is going to be doing an all-sky survey, so it's going to take in the entire sky. So it's like a wide-angle lens on the universe, and we'll be doing mapping of galaxies, as I mentioned earlier, more than 450 million galaxies that will go to a significant depth back in cosmic time. It'll be complementary to other surveys that are being done by other telescopes, both in space and on the ground. And together, these missions will help us understand the evolution and formation of galaxies and star formation in galaxies, as well as putting together a better picture of what happened during the physics of the very early universe, just instant after the Big Bang.
Great. Thank you, Jim. We have another question on the phone line. Up next is Janine Scully, Newshawk.
Hi, just a quick question. Do we know how long Punch is designed to operate? And you've kind of touched on this a bit, but can you just say more bluntly how exactly these missions help us on Earth? And kind of, I know like solar wind can affect telecommunication systems. Anyways, can you help us kind of just bring it down to that kind of level for the readers?
Would you like to start, David, and then Mark?
Sure. So Punch is going to be able to create a three-dimensional map of the solar wind and coronal mass ejections as they come off the sun. The benefit to us is that we'll be able to, with this information over time, we'll be able to better model the way these particles are coming off of the sun, so that we'll better be able to forecast when they're hitting the Earth, the magnetosphere of the Earth, and so that way we can understand better when do we actually expect outages or disruptions to communications or GPS signals. So those things really apply to how we do that. And I don't know if I got the whole question though.
So I can try and address part of this. So I think it's well understood that the activity of the sun and space weather has potential to have major societal impacts, and it can impact our technology, cause satellites to re-enter sooner than they should. In fact, I'm sure Juliana could talk about an occasion that Starlink suffered a couple of years ago when we had some early re-entry of their satellites. But really bad space events can shut down our power grid, interrupt telecommunications. So it's a real threat that we need to be able to understand, and most importantly, be able to predict or forecast. And a key part of being able to forecast is to have the physical understanding of when these events might occur. And that really requires the understanding of these physical processes. And that is what we are building Punch to help us understand. So the more we understand about how the sun works, how these events occur, the easier it is in the long term to improve our ability to forecast them.
Thank you, David and Mark. And up next on the phone line is Madison Quark with Maddie Sierra Photography.
Hi. Are there any concerns about the reports of a 50% budget cut for NASA science and the current DOGE cuts causing complications and ability to complete the planned mission lifespan of both SPHEREx and PUNCH? Thank you.
So I think that one's for me. I think it's fair to say that right now, all of the articles talking about potential budget cuts are just speculation, and we have no guidance as yet. And so we are continuing to do the science that we do every day at NASA and produce the benefits to our society that science provides.
Great. Thank you, Mark. And to follow up on the previous question, the other half was, how long was Punch designed to operate?
Thank you. The Punch is designed to operate for 2 years.
Great, thank you. And we are taking some more social media questions. This one is for you, Jim. Adu on X wants to know, when will SPHEREx start providing us with pictures?
SPHEREx is an infrared telescope, and therefore it has to be very cold. And it's going to take us about 2 weeks for our telescope and the detectors, the sensors that take the images, to get into a temperature range where we can actually turn them on and take data. The first data that we take will be used for processing on the ground. We'll use it for making adjustments in how the observatory operates and how it performs its surveys. But I would expect that we'll certainly get initial images before the end of our in-orbit checkout period, which nominally runs for 37 days. So the exact timing of that will depend on how the data processing is going and how the checkout of the vehicle is going.
And we have another question on SPHEREx with Matthew Henderson on YouTube, who asks, what will SPHEREx do differently than James Webb?
So I think the best way to compare a telescope like SPHEREx to Webb or the Hubble telescope is to use a photography analogy. The Hubble telescope and James Webb were designed to give you the maximum resolution, the most zoomed in look on objects that you can get. So they're larger telescopes and they have much better imaging resolution, but their fields of view tend to be small. Survey missions like SPHEREx are very wide angle lenses. So it's like the difference between zooming in and getting a portrait of an individual in a crowd versus taking a wide-angle panoramic picture and getting, an idea of the entire population. So they're very complementary. Many of the objects that we'll discover in the SPHEREx survey will be interesting to astronomers, and we'll want to have closer-up look. We'll want to use the power of the James Webb to look at specific objects and phenomenon with a powerful suite of instruments that can be brought to bear. So you can think of SPHEREx as surveying and finding objects that can be followed up on with the very long telephoto lenses, if you will, for machines like Hubble and the James Webb.
I could just add to that.
Absolutely.
So I would just add to that by saying any time that we have brought online a new capability, one of the things that we always find is it finds new targets that astronomers want to go look at, or new phenomena, and that's where we bring to bear our other astrophysics mission assets, in this case like James Webb or the Chandra Telescope or SWIFT. So the two are very complementary. Surveys are great in helping you find new things that you can then follow up with the sort of deep stare that these other observatories give you.
Thank you both. And back on the phone line, we have Will Robinson-Smith with Spaceflight Now.
Hi, thanks for allowing a second question. This one to James Fanson. The SPHEREx telescope is, please correct me if I'm wrong, will be mapping the sky 4 times across its planned operational life. How was it determined that 4 was kind of the sweet spot in order to get the full 3D map set you're going to be creating? And would more times be able to provide a more robust data set and refine the imagery, or did you feel like 4 was pretty much bang on for what you want to accomplish with the science? Thanks.
Thank you for that question. The mission design, or the survey design for SPHEREx, takes advantage of the particular orbit that we're in. This is a sun-synchronous orbit, and the orbit precesses around the Earth at the same rate that the Earth orbits the sun. And that means that we can always keep the solar panel pointed at the sun and the telescope pointed basically 90 degrees or thereabouts from the sun. And that gives us a narrow strip of the sky basically above from the Earth through the telescope straight out into space. As we orbit the Earth, we can scan or image a strip of the sky. And every time we orbit, that strip precesses slightly, such that 6 months after 6 months has elapsed, we can cover the entire sky. So the 4 surveys will give us an opportunity to get the completeness that we want on the survey. Not every moment of every orbit will be spent collecting data. We do have to spend time communicating down with ground stations, and there's usually some kind of maintenance work that we'll have to do during the mission. So there will be some gaps that will be encountered, and then we can fill those gaps in as we do the 2nd, 3rd, and 4th all-sky survey. I should say that we carry no consumables on the SPHEREx vehicle. There's no propellant, there's no cryogen, there's nothing to be depleted during that 2-year mission. And so we're optimistic that we'll have an opportunity for an extended mission with SPHEREx. And of course, the more scans we do of the sky, the more sensitive the data in the archive becomes.
Thank you, Jim. We will now take some more social media questions. Dr. Zowie on YouTube asks, how does Punch see the solar wind in 3 dimensions? I think that one's for you, David.
So the imagers on Punch, they have polarized filters. So as the polarized filters change direction, so you have different angles, with the polarized filters allows us to get directionality on the light that we're measuring. And with that, we can reconstruct the direction and where those are. So that gives us a 3-dimensional view of the solar wind.
Great, thank you. And Jim, you touched on this a little bit just now. Nelson Nilsi on YouTube asks, can you describe what kind of orbit SPHEREx and Punch will be in, and what are the advantages and disadvantages for these orbits?
Well, I'll speak for SPHEREx. The orbit that we're in is an orbit that basically follows what we call the terminator, or the area where we go from sunlight to shadow. And it passes over the poles of the Earth. And one of the beauties of that orbit is that, as I mentioned a moment ago, we can always be in the sunlight. So we can always have a stable thermal environment. We can always have sunlight on the solar panel to generate power. And it gives us a good strip of the celestial sky that we can view at each orbit as we go around the Earth. And the orbit precesses so that after 6 months we can cover the entire sky. So it's a very efficient method that's been used by other missions. We're not the first to use this type of an orbit. I would say that there's really no disadvantage for the type of thing we're doing with SPHEREx to this orbit. Each telescope we put into space has a special purpose and a special mission design, and often the orbit is part of that selection. For example, James Webb is out at the Lagrange point, out beyond the moon. Other telescopes are in different orbits, and for doing an all-sky survey like this, this orbit is very efficient.
Thank you, Jim. David, would you like to talk about Punch's orbit?
Sure. With Punch, we're trying to look at the sun all the time. So the same orbit where SPHEREx gets to use the sun for power and other things, we get to stare at the sun all the time. So 100% of our time is looking at the sun and taking images. And at the same time, the spacecraft are designed so they can do communications and all the things that they need to do maintenance-wise while taking images. So this is a great orbit for us to be able to do our science. I don't think there's actually any disadvantages at this point to this orbit.
Great, thank you. We have a couple more social media questions. The one from Lulu Garcia Hernandez on X wants to know, what discoveries do you expect from SPHEREx?
SPHEREx is designed to explore 3 main themes in addition to creating this very rich archive that will be used by the community for a long time. The first of these is to understand what happened at the very instant after the Big Bang. We've known for about 100 years that we live in an expanding universe. If you run the clock backwards, the universe seems to have originated in a singularity that we call the Big Bang. But there are aspects of the universe that we observe that are not easily explained, and there's a framework that since the 1980s has become basically the standard accepted framework for understanding the early universe, called cosmic inflation, where the universe underwent this tremendous exponential expansion in the first fraction, small fraction of a second after the Big Bang. And modeling that process of cosmic inflation is challenging. There are many models that fit within the general framework, but we need more data in order to determine which of those models actually reflects what likely happened at the origin of the universe. So that's one theme. Another theme has to do with understanding the history of galaxy formation over cosmic time. And there we're going to be imaging the entire sky, looking to inventory, if you will, all of the light that has ever been emitted by galaxies over the age of the universe that we can observe in the wavelength range that we're observing in. And from that, we'll be able to tell something about how when galaxies formed, how they evolved, the period that we call cosmic noon, where star formation in galaxies reached its peak and then seemed to gradually die off over time. So we'll be studying that as the second theme. And the third theme is really to understand where the water is in the galaxy and in the universe on a large scale, for that matter. But we believe that most of the water in the galaxy is in the form of ice that has attached itself to very small dust grains. And these dust grains exist in clouds in between the stars, and somehow that material finds its way into new planets as they're forming around stars. And indeed, we believe the water that is on the Earth was transported here during this process of solar system formation. So we're trying to inventory where these ices are, ices made of water and other organic molecules, and try to, again, understand better how that planet formation process forms and how water finds its way into planets, which we believe is needed for any form of life that we recognize on the Earth.
Thank you, Jim. And that will do it for our press briefing today. Thank you so much to our speakers, and thank you in your interest with SPHEREx and PUNCH. So for the latest updates on the SPHEREx mission, visit blogs.nasa.gov/SPHEREx. And for the most recent PUNCH updates, visit blogs.nasa.gov/PUNCH. We hope you can join us for tomorrow's launch attempt. Live launch coverage begins at 6:15 p.m. Pacific Time on NASA Plus and on NASA's social media platforms. Thank you so much for watching.